Hello, and welcome back to the channel. Have you ever looked at your email inbox and just marveled at how it magically knows which messages are junk and which ones are important? You see that spam folder perfectly filtering out the noise? Or how about when Netflix uncannily suggests a movie that you were just thinking about watching? It's not magic, and it's not a psychic on the other end. It's a powerful type of artificial intelligence called supervised learning. And today, we're going to pull back the curtain and demystify exactly what that is, how it works, and why it's the engine behind so much of the smart technology we use every single day. So, grab a coffee, get comfortable, and let's dive into the fascinating world of teaching machines. So, what exactly is supervised learning? Let's break it down with a simple analogy. Imagine you're training a new puppy. To teach it to sit, you guide it into a sitting position, say the word sit, and then give it a treat. You repeat this process over and over. The puppy starts to associate the command sit with the action of sitting and the reward of a treat. You are supervising its learning process by providing clear examples and feedback. Supervised learning works in a very similar way, but instead of a puppy, we're teaching a computer algorithm, and instead of treats, we use labeled data. Let's go back to our email spam filter example. To build this filter, developers feed the algorithm a massive data set of emails. But here's the crucial part. Every single one of these emails has already been labeled by a human. This one is spam. This one is not spam. This one is spam. This one is not spam. The algorithm, or what we call the model, meticulously goes through thousands or even millions of these labeled examples. It's looking for patterns. It starts to learn that emails with phrases like "you've won $1 million" or "click here for a limited time offer" often get labeled as spam. It also learns that emails from your contacts or those that use your name are usually labeled not spam. After this intense training phase, where it has studied all the labeled data, the model is ready to be tested. We give it a brand new, unseen email one it has never encountered before. Based on the patterns it learned during training, it makes a prediction. I think this is spam, or I believe this is not spam. The more well-labeled data it was trained on, the more accurate its predictions will be. In essence, we're supervising the computer by showing it the right answers up front so it can eventually figure out the answers for itself. It's like giving a student an answer key to a bunch of practice problems so they can learn the method and then ace the final exam on their own. No. Let's talk about the two main types of problems that supervised learning excels at solving: classification and regression. These might sound like complex technical terms, but the concepts are actually quite straightforward. First, let's look at classification. Our spam filter is a perfect example of a classification problem. The goal is to assign an input to a specific category or class. Is this email spam or not spam? It's a choice between distinct categories. Another example would be in medical imaging. A model could be trained on thousands of labeled images of skin moles to classify them as either benign or malignant. Or think about a bank trying to determine if a credit card transaction is fraudulent. The model classifies the transaction as either legitimate or fraudulent. In all these cases, the output is a discrete label, a specific category. On the other hand, we have regression. With regression problems, we're not predicting a category, we're predicting a continuous numerical value. Think about a real estate website that estimates the price of a house. The model is trained on a data set of houses where it knows features like the number of bedrooms, the square footage, the location, and, crucially, the final selling price. The algorithm learns the relationship between these features and the price. So, when you input the details of a new house, it doesn't tell you if it's expensive or cheap. That would be classification. So, it sounds amazing, right? But like any technology, supervised learning has its own set of pros and cons. Let's start with the biggest advantage: accuracy. When you have a large, clean, and accurately labeled data set, Supervised learning models can achieve incredibly high levels of performance. They are often the gold standard for many tasks because the training process is so direct and clear. The model knows exactly what it's supposed to be learning, which leads to reliable and predictable outcomes. This is why it's so widely used for critical applications where mistakes can be costly, like fraud detection or medical diagnosis. The results are often highly interpretable, meaning we can understand why the model made a particular decision. However, there's a significant drawback, and it's the flip side of that same coin. The reliance on labeled data. This is often the biggest bottleneck in a machine learning project. Getting that data and labeling it is a massive undertaking. Imagine having to manually go through 1,000,000 emails and label each one as spam or not spam. It's time-consuming, it can be expensive, and it requires a lot of human effort. This process, known as data annotation, can sometimes cost more and take longer than building the actual model itself. Furthermore, if your labeled data is of poor quality, if it's mislabeled or doesn't represent the real world accurately, your model will learn the wrong things. This is the classic garbage in, garbage out principle. A biased dataset will lead to a biased model. So, where do we see supervised learning in action in the business world and for tech professionals? The applications are virtually limitless. For e-commerce businesses, it powers recommendation engines, suggesting products you might like based on your past purchases and browsing history. This is a huge driver of sales. In finance, it's the backbone of credit scoring, assessing the risk of lending money to an individual. Hedge funds use it to predict stock market movements. In marketing, it's used for customer sentiment analysis. Companies can analyze social media comments, reviews, and customer support chats to automatically classify the sentiment as positive, negative, or neutral. This gives them invaluable real-time feedback on their products and brand perception. For tech professionals, understanding supervised learning is fundamental. Whether you're a data scientist, a software engineer, or a product manager, this tool allows you to turn raw, messy data into concrete, actionable insights that can drive business strategy and create innovative new features. It's the skill that allows us to build truly smart applications. From predicting customer churn so you can intervene before they leave, to optimizing supply chain logistics. Supervised learning is translating data into value across every single industry. Let's bring it back to you. The next time you unlock your phone with your face, that's a classification model at work. When your music app creates a personalized playlist for you, that's a regression-like model predicting songs you'll enjoy. When you see targeted ads that seem a little too relevant, that's supervised learning analyzing your digital footprint. It's the invisible architect shaping much of our digital experience. It's not some far-off futuristic concept. It's a practical tool that is already deeply embedded in the technology we rely on. And while we've focused on supervised learning today, it's important to know it's just one piece of the machine learning puzzle. There are other types like unsupervised learning where the data has no labels and the model has to find hidden patterns on its own, and reinforcement learning where a model learns by trial and error like a computer learning to play a game. We'll be covering those in future videos, so make sure you're subscribed. So, to recap, supervised learning is about teaching a computer by showing it examples with correct answers. We use labeled data to train a model to make predictions on new, unseen data. It excels at classification predicting categories and regression predicting numbers. While it's incredibly powerful and accurate, its biggest challenge is the need for high-quality, labeled data. But despite that hurdle, it remains one of the most impactful and widely used forms of AI, turning business data into business intelligence and making our tech feel just a little bit like magic. Thank you so much for joining me today to explore the world of supervised learning. I hope this cleared things up and gave you a better appreciation for the incredible technology working behind the scenes. If you found this video helpful, please give it a thumbs up. It really helps the channel. And if you have any questions or want to share examples of supervised learning you've noticed, please drop them in the comments below. I love reading them. Don't forget to subscribe and hit that notification bell so you don't miss our next deep dive into the world of AI. Until next time, stay curious.